In Lesson 3-4, we will discuss exponential and logarithmic equations. In video 3.4.4, our learning target will be for students to be able to solve exponential equations. In example 4a, we're asked to solve the exponential equation 3 to the x equals 7 and round to the nearest hundredth. Now, in order to solve an exponential equation, we need to solve for x, which is an exponent, hence why it's called an exponential equation. And in order to do so, anytime we are solving for a variable, which is part of an exponent, we need to use logarithms. We are going to use logarithms to solve exponential equations because logarithms are the inverse of an exponential equation. Logarithmic equations or logarithmic functions are the inverses or inverse of exponential functions. So therefore, in order to undo an exponential function, we have to use logarithms. Now, here's the deal. We have 3 to the x equals 7, and we know anytime we do anything to either side of the equation, we have to also do that same thing to the other side of the equation to keep the equation balanced. So if I start by taking the log on the left side of the equation, I also have to take the log of the right side of the equation. Now, what the logarithm does for me is I can apply the power property of logarithms, which states that I can bring that exponent or power down out in front of my logarithm and multiply it by log base 3. So log of 3 to the x power is the same as x times log of 3 by applying the power property. I still have log of 7 on the right side. And to solve for x, since I'm multiplying x times log of 3, I can divide both sides of my equation by log of 3. And x equals log of 7 divided by log of 3. Now, I can calculate this on my calculator because my logarithm is in base 10. And when I type in my calculator log of 7 divided by log of 3, I get 1.77. What this means, if I want to check my answer, is that 3 to the 1.77 power is approximately 7. Again, I'm not going to say it's exactly equal to 7 because I rounded my answer. In example 4, part B, we're asked to solve the exponential equation e raised to the 2x plus 1 equals 8. We need to round our answer to the nearest hundredth. Now, if I refer back to what we discussed in the previous example, since x is part of an exponent, I'm going to need to take the logarithm of both sides of my equation in order to bring that x value down by applying the power property. Now, in the last example, I used the common log, log, or log base 10 on both sides. In this example, since my base is e, I'm going to use the natural log on both sides. I'm going to take the natural log of both sides of my equation. And it doesn't really matter. I could use a common log here, log base 10. But the reason why I'm using natural log is because natural log is base e. And so it's going to help me simplify my equation much faster than common log would. So if I apply the power property states that I can bring down the 2x plus 1. And I'm going to multiply by natural log of e. Remember, my natural log is base e, and if I use the property where with natural log or common logs, if your base on your log is the same as the base of your input, they cancel out, and they would just leave me with 1. Natural log of e is equal to 1. Natural log of e is equal to 1 because e to the first is equal to e, if I rewrite it exponentially. So I have 2x plus 1 times 1, which is 2x plus 1, is equal to natural log of 8. I'm going to then take natural log of 8 and subtract 1 from it. That would get rid of this 1 here. I would subtract 1 from both sides. And then to get x by itself, I would divide by 2. So x is equal to natural log of 8 minus 1 divided by 2 gives me an x value of approximately 0.54 if I round to the nearest hundredth. Now, on my calculator here, I can go back in and substitute 0.54 for x. So if I took e, which is on my calculator second and natural log, that's how you get the e on your calculator. So if we raise e to the 2 times 0.54 plus 1, that gives me 8.004468914, which is approximately 8. If you round x to the nearest hundredth, when you go back to check your answer and plug in for x here, you're not going to get exactly 8. You would have to use all the decimal places of natural log of 8 minus 1 divided by 2 in order to get exactly 8 when you check your solution. In example 4 guided practice, I would like you to solve 4 raised to the x equals 9 and round your answer to the nearest hundredth. You have 4 choices, A, B, C, and D. I would like you to go ahead and solve the exponential equation using logarithms like we did in examples for part A and part B. Work out your solution and then press submit.